Hey everyone, this lecture is 7.1. This is for that missed day that school closed early because of the big weather. So, but this video will be posted on YouTube. And remember, you also have the Alex video as well, found on the Alex software online. So again, the name of this section is 7.1, and it is quadratic functions. Remember, you can always pause this video and stop it, rewind it, and stuff like that. As you can see, I don't have that much space to work with, so I will be doing a lot of erasing. Now, what's nice about quadratic functions is you actually have seen it before. You even saw it in your previous math course. Remember, a quadratic function, this right here, that's just a parabola. It's just a really fancy way of saying it's a parabola. Now remember, parabolas are the U-shaped functions, right? And if you remember from the last set of material, we saw that in transformations, like this was a parabola, right? Like you'd have something like that. You could have something like this. It could be anywhere, right? It could open up and down or left and right. But in our case right now, we're just gonna be looking at it whether they specifically open up or down, like in this instance right here. And parabolas or quadratic equations or functions, they have unique terms to describe them. Like all quadratic equations or functions or parabolas, they all have a vertex. So the vertex, I'll keep it in green, is the highest or lowest point So PT stands for point, highest or lowest point of your quadratic function. So if it was the highest point, like in this case right here, we would say the vertex is the maximum point. Or let's say this case right here, the vertex is the minimum point, right? Because that's the smallest point that our curve gets to or goes to. So the vertex is the minimum. So that's something that they all share in common, parabolas or quadratics. They're all U-shaped. They all have a max or a min, a vertex, right? Depending on where they open up or down. Now we can tell if we were given the curve, right? Like if it was drawn out, oh, that vertex is the max. Or yeah, that parabola opens up or it opens down. But what if you were specifically given an equation? How could you tell, right? So let's look at that. Now there's two ways that you'll typically see a quadratic function written out, or two forms. And one way you definitely have seen before when you have solved a quadratic equation or the quadratic formula. So two forms of a quadratic equation. So the first one is we have this right here, like f of x equals a times x minus h squared plus k. This is sort of kind of like the new one right here. The second one, the one that everyone has seen definitely for sure, is this, ax squared plus bx plus c. Both of these are two forms in which we can represent a quadratic equation, right? Like this one, remember when we factored You had the quadratic formula that was used from here, right? This one we sort of kind of have seen. If you recall from the transformation section, remember when we'd shift stuff around, right? Like this was kind of like a parabola. This H was like the horizontal shift, right? And you go in the opposite direction of what that number is. This K, that was like a vertical shift, right? Wherever the sign of that was, you'd move your graph either up or down. Now how can we tell whether or not the parabola is going to open up or down without even graphing it? Well, it's the sign of the A. Okay, so and this works for both of them, okay? If A is greater than 0, meaning it's positive, then the parabola opens up. So it would look, something like this right here. Well, if it opens up, right, then what does our vertex have to be? The vertex is automatically a minimum point. And again, that applies to both equations, okay? So as long as A is positive, it opens up. Now, what if A is negative? Or if A is less than 0, the quadratic equation or function so EQ stands for equation, opens down. So that means in that instance, we could have something like this. Well, in this instance right here, your vertex, remember that's either the highest or lowest point, would be a max. So if A is less than 0, the quadratic equation opens down. Basically, if A is negative. Now that should ring a bell because remember, if we come back to this form, remember when we were talking about transformations, if you had a negative in front of the X, like outside of it, what did that do? That flipped it over the X axis, right? Remember that? The curve would open down if A was negative in that instance. So the same rule still applies right here in this form. Same thing down here. If this was a negative A, it's still going to open down. But in this section right here, we're going to go into more detail as to how to graph them more accurately. Okay, so let's go and look at this specific form right here, this first one, because there's some more data that we need in order to graph these, right? Like a lot of parabolas, well, they all have a vertex, right? Either a high or low point. They can also have x-intercepts, y-intercepts, something called the axis of symmetry. So we're going to go over all that right now. So we're going to start with the first form and do a couple of those problems, and then do a few problems in this form right here with the second one. Now, as I mentioned before, in order to graph a parabola accurately, first of all, you need a vertex, and then we need x-intercepts and y-intercepts if possible, and also an axis of symmetry. Well, you don't really need that, but they do want to know what it is. But you at least need the vertex and a couple of points, or some nice points. And again, those nice points can come from you creating a t-table, or what's better is finding the x-intercepts and y-intercepts. Now, what's really nice about this form right here, this first form, is that we can easily tell what the vertex is just by looking at it. And that comes from, again, the transformations. The vertex from form 1 is just h comma k. So again, remember that's the horizontal transformation. We would go in the opposite direction for the h. That's why the sign flipped. And for vertical transformations, whatever this was, the sign didn't flip. So if that was minus k, if you shifted down, if that was like -5, you would go -5 down along the y. For the h, remember, you go in the opposite direction. That's why this is plus h right here. But if this is like x plus 4 squared, you would go to the left -4. So remember, you flip the sign for the H always. The K stays the same. A, remember, tells you that was a vertical stretch or shrink from the transformation section. But in this case right here, all that we really care about is that, oh, if A is positive, the parabola opens up. Or if A is negative, it would open down. So let's check out a problem. Like, let's say we have this right here. We have f of x equals x plus 2 squared minus 1. And we want to figure out, does it open up or down? Let's figure out the vertex. And then x-intercepts. Also y-intercepts. And then we'll sketch the function. We also want the axis of symmetry. And then the max or min value. And then also the domain and range. So and range, domain and range. So lots of stuff, right? Anything else can take forever. No, it's not going to take that long. A lot of them we can tell just by looking at it. So for the first question, it's asking, hey, does this graph open up or down? Remember, what determines that? It's the A, right? This is in the form A times x minus h squared plus k, right? Remember, if A is positive, it's 1 in this case. Since A is greater than 0, because remember, it's 1, the parabola opens up. If A was negative, like if we had a negative out in the front, or if it was like -10, for example, then it would open down instead. Now, what's the vertex? Well, again, because it's written in this form, the vertex is just h comma k. So we flip the sign of the h, or we flip the sign of that number on the inside, because remember, that's horizontal transformations. It would go in the opposite direction. So instead of it being +2, it's going to be -2 for the x. But for the vertical, the k, you notice from the formula, we did not flip the sign. So it's just -1. So -2 comma -1. That is the vertex right there. If this was x minus 2 squared, then this would be a +2 right here. Now, for the third one, it says find the x-intercepts. So remember, to find the x-intercept, I told you that never ever changes. Even if you get to math 1,000,000 and they say find the x-intercepts, what do? Remember, the trick was you let y be 0, right? And then we solve for x. Okay, so remember, f of x is like a fancy way of saying y. So we set this equation to 0 and we solve for x. So we have x plus 2 squared minus 1 equals 0. Got to solve it, right? So we need to isolate this squared term. So we add 1, and we get x plus 2 squared equals +1. Now we need to get rid of the squared here. What undoes a square? A square root, right? Do that. And then remember, the square root of something squared, they cancel each other out. So we get x plus 2 equals, Now remember, because we're dealing with equations and we took the square root, we're going to have two answers. So we're going to have plus or minus 1. Don't forget that. Now we have two equations to solve for, right? We have x plus 2 equals 1, positive 1, and x plus 2 equals negative 1. But then when you solve it, you get x equals negative 1 and also x equals negative 3. Now remember, these are points, right? X-intercepts, what they have in common is that their y value or component is always 0. So how would we plot an x-intercept of negative 1? That would be negative 1 comma 0. Just like this one would be negative 3 comma 0 right there. So keep that in mind. Let me write this down. So now we have the x-intercepts. Let's find the y-intercept, right? Because that was the fourth step. Now remember, for the x-intercepts, we let y be 0. The y-intercept is the reverse, right? We let x be 0. And then solve for y. So what does that mean? It's now we have y equals 0 plus 2 squared minus 1 because we're substituting 0 in for x. So this is not too bad, right? Because this is just 2 squared minus 1. That's 4 minus 1, which is 3. Now, what is this as a point? Remember, for all y-intercepts, x is 0. So this is the point 0, comma 3, right? It's important to realize what it is as a point. We're talking about points here. Points have two components, an x and a y. So that was the y-intercept. Now the fifth part is saying let's sketch the function, right? And what do we need? We need the vertex. We got that. And we have some other nice points, which are the x-intercepts and y-intercepts. But first, let's go ahead and plot the vertex. So that, remember, the vertex was negative 2 comma negative 1 down here. Negative 2, negative 1. Boom. There's our vertex. And since the A was 1, remember it was positive, it should open up. So our graph better be doing something like this, right? If it's opening down, we did something wrong. Now let's plot the intercepts, right? So the x-intercept was, we had two of them, negative 1, 0, and negative 3, 0, right? Remember, x-intercepts are where the line crosses the x-axis. The y-intercept is where the line crosses the y-axis, and our y-intercept in this case was 0, 3, which is right here. So if you notice now, we have a nice U, right? Nice little U shape. We should always have a nice little U shape as we're working these out right here. And it's opening up because A was positive right here. If A was negative, it should open down. All right, now, the next question was asking for the axis of symmetry. So basically what this is if y'all remember from the previous sections, we talked about even symmetry, right? It was like, oh, if I could throw a mirror along the y-axis, I could take one half of the curve and flip it over the y-axis and it would land on itself. And that signified even symmetry. What this wants is, it's not worried about, oh, is it along the y-axis? It wants us to create some kind of axis somewhere that's going to make this symmetric. So they're basically saying, where can I place the mirror so that this thing, such that if I reflect it over itself, it's going to land on its other half. So if you notice, if I put the mirror here, right, like this red line's the mirror, I could take this side and flip it over, land on itself. I could take the right side, flip it over the red line, and it'll land on itself. What is this red line right here? This is the line x equals -2. This is the axis of symmetry. Now, did I guess on this, or did I have to sit here and experiment to figure out the axis of symmetry? No. What's really nice about the axis of symmetry is that it's always x equals the x part of the vertex. So where did that -2 come from? The vertex, right? What was the vertex in this case? Remember, the vertex was -2 comma -1. So once you find the vertex, you already have the axis of symmetry. It's just x equals whatever the x component is of your vertex. Really important, you have to put x equals. You can't just say -2 is the axis of symmetry, because we need this line right here. What creates a line is an equation. If you have a vertical line, what's the only way you can create a vertical line on the rectangular coordinate system? Is by having x equals only. There's no y's because that's a horizontal line. We need a vertical. So you always have to put x equals and then whatever the x value is from your vertex. It's always going to be that. It's never going to change, okay? So if the vertex was 8, 7, your axis of symmetry would be x equals 8. You just take this number and copy it right here with the x equals, and you're done. That's all you need to do for the axis of symmetry. Then the 7th question is asking, oh, what's the maximum value, right? Well, we already have that, right? The maximum value is the vertex. But remember, what is this right here? Is this the max point? No, that's the min. So the vertex in this case is the min point in this case. So your answer is, what is the answer? -2 comma -1. Where am I getting that from? It's just the vertex again. That's it. That's all that it is. If this wound up being the max, like it opened down, guess what? The vertex is still the answer for that, because that's the minimum. It's the min in this case. Parabolas can only have a max or a min. They can't have both together, okay? So in this case, it's the minimum value, which is -2, -1. That is your answer right there. And the last part was asking us to determine the domain and range, right? Always coming back to that. And of course, they want an interval notation, right? Domain is all the x values that our line exists at. Remember, it has 2 arrowheads pointing to the left and up, and pointing to the right and up. Well, pointing to the left means that it runs forever to the left, correct? So if I kept drawing this, it would go out that way forever. Where is it going forever out to the left? -infinity. Same on the right side. It's going to the right forever. What goes way off forever along to the x, to the positive side? Positive infinity. What always goes around infinity and -infinity? Parentheses. Now for the range. Remember, it's the y values, right? Smallest y value to the largest y value that our blue curve is going to, or reaching. What's the smallest y value? Well, it's definitely not negative infinity because we don't have any arrows pointing down. So the smallest y value is here. What is that? It's -1, right? What's the largest y value that the blue line goes up to? Well, we have some arrowhead pointing up, right? It doesn't matter that both of them are pointing up. We just need one of them to point up because that signifies it's going up forever. Well, what's way up here forever and ever and ever? Positive infinity. And what are we going to put around the -1? A bracket this time, right? Because there's no open circles or anything like that. The blue line's running through -1, right? Remember, if there's no circles or anything like that, it's automatically included. And of course, with the infinities, we get parentheses around those. So that's one example of this form right here. Let's do another one. All right, so again, we want to see if it opens up or down, vertex, x and y intercepts, axis of symmetry, all that good stuff. So first one, opens up or down. Remember, it's a times x minus h squared plus k. So if a is less than 0, negative, which it is right here, remember that tells us it opens down. So we know our graph is going to be doing, something like this, right? Oops. It's going to be opening downward. Opens down. Looks something like that. So that means our vertex is going to be a max, right? It's going to look something like that. Now, what is the vertex right here? Remember, the vertex is h comma k. So we flip the sign of this x value right here. So it's 1 comma, but we don't flip the sign of the k, right? Because remember, vertex was h comma k. This is 1 comma 8. The third thing is the x-intercepts. Remember, to figure that out, you set it to 0, right? We let y be 0 and solve for x. So we have -2 x minus 1 squared plus 8 equals 0. We need to isolate that squared term right there. How do we do that? Got to subtract the 8 first, right? And then we get -2 x minus 1 squared equals -8. Then we need to divide by -2. And then we get x minus 1 squared equals +4. Got to get rid of the square root. What undoes the square root? I mean, a square. What undoes a square? A square root does. And then we get x minus 1 equals not only 2, but plus or minus 2. And again, that gives us two equations, right? We have x minus 1 equals 2 and x minus 1 equals -2. So one x-intercept is 3. Another one is -1. Because again, I'm just adding 1 to both sides right here. And then what are these as points? This is 3 comma 0. This is -1 comma 0. Just like that. Now the fourth part was to figure out the y-intercepts, right? Then for y-intercepts, we let x be 0 and we solve for y. So we get y equals -2, 0 minus 1 squared plus 8. So what does that give us? We get y equals -2 times, this is -1 squared plus 8. Watch the arithmetic. This is -2 times +1 plus 8. And then this is -2 plus 8. And then you get 6. What is this as a point? 0, comma 6, right? Because all y-intercepts have an x-intercept of 0. So now we have all this wonderful information, and we can graph our curve. So that was like the 5th one where we'd actually draw the sketch. Ah. Okay, so this is 9 up here. The vertex was 1, comma 8, so something like right here. And remember, you can always pause this video, right, and rewind and fast forward and all that. And it was opening down, correct? Let's see if our points make sense. So remember, we had 3, comma 0 as an x-intercept. We also had -1, comma 0 as an x-intercept. And then our y-intercept was 0, 6. So if we sketch this out, again, it looks like a nice U that is definitely opening down. If you're plotting your points and you can't make a nice U out of it, then you did something wrong, right? You need to go back and check the signs of your arithmetic right here, right? Or did you set the right pieces to 0 for the intercepts? Did you remember to flip the sign for the x value right there? If you don't, it's going to look all wonky. Okay, so again, if it's not like a nice U that opens down or up, you need to go back and check your work. Most likely you forgot to flip the sign inside of here. If this was x plus 1, the vertex would have been 1, comma, whatever this number is right here on the outside. So now that we have our curve, the next thing is the axis of symmetry, right? We want to figure out what is this line right here, this blue line. That would make this symmetric, right? Meaning if I could flip this over the blue line, it would land on itself. Doesn't matter which side. And remember, for that, it was always x equals the x part of your vertex. What is the x component of our vertex? +1, right? Because remember, the vertex was 1, comma 8. So again, whatever that is, you flip the sign, and that gives you the x component, and there you go. So that's our axis of symmetry. Really important, the answer is x equals 1, not just 1. We need the x equals in order to get that vertical blue line right there. Now, the next part was, oh, what's the min or max value? Well, in this case right here, we have a max, right? A max value. Why? Because the graph, the parabola opens down. This is the highest point right here, so it's got to be the max. What is that max value? It's always the vertex. The max or the min value is always the vertex of that particular function, is 1, comma 8. Again, where am I getting that from? That's just the vertex right here. That's not changing. It's always going to be that piece of information. So you see, once you discover the vertex, you already have 3 other answers, right? Or 2 other answers. You have the axis of symmetry, which is the x part of the vertex. You also have the max or min value, because that's also the vertex right there. Now, let's say you have a function like this, and they want it in a times x minus h squared plus k form. So when you convert it, kind of like, remember when we were doing those circle problems and they gave us that weird big long equation and they said, I want the center and radius. We had to convert it into standard form. This is the same thing right here. We want to convert this trinomial into this quadratic equation form right here. So now we can see what the vertex is, right? Super easy. So how do we do that? Well, the first thing you want to do is make sure a is equal to 1 right here. So when I say a is equal to 1, I'm not talking about this a. I'm talking about this right here. Must equal 1. Okay? If you notice right now, it's not equal to 1. It's equal to 3. A equals 3, which does not equal 1. So what do? We just skip the problem, right? Because I can't work it out. Nope. Unfortunately, we actually can do something about it. If a is not equal to 1, very important, if a is not equal to 1, which is not in this case, you need to factor that out. So what are we going to do? Be very careful. You're only going to factor this out from the first two terms. So this is going to become 3x squared plus 4x, and then the plus 5. Now let's see what I did right here. That the c did not change. Notice that. Only from the a and the b did I factor the 3 out. You will always do that in these instances. You only factor out whatever this number is from the first two terms. Remember, factoring out means dividing out. How can I check my work? If I distribute the 3 back in, I get 3x squared plus 12x. You must do this step. All right, if a is not 1, you have to divide out whatever that is from the first two terms. All right. So now we have a is equal to 1, right? And I have the b and the c right here. The next step that you're going to do at this instance is you are going to complete the square. Okay? That's the second step. So now we're completing the square is b over 2 squared. What was b in our instance? 4. So you're going to have 4 over 2 squared, and that's just 4, right? Because 4 divided by 2 is 2. 2 squared is 4. Now, what are you going to do with that? Remember, we completed the square with the circle problems. We added it to both sides. Well, you're going to do something similar like that over here, but we're going to have this. This will now become 3, and then x squared plus 4x, and I'm gonna leave this 4 here in red. So what we're going to say plus 4 minus 4 and then plus 5. So really important, look at what I did with this 4 that I got from b over 2 squared. I kept it inside of that parentheses right here. I added it and I also subtracted it. Remember, this is mathematically legal because what's 4 minus 4? It's 0. So you haven't really modified this at all. You've just added and subtracted it. You've added a fancy 0 to this. This 4 minus 4 is a fancy 0. Where did that come from again? From completing the square. If you did b over 2 squared and you got 7, you put plus 7 minus 7. Or if this was 22, you put plus 22 minus 22. But notice you have the positive and the negative next to each other, and they are still trapped inside the parentheses. Now, the third step. The third step is to factor what's inside of this. We want to factor this part right here. Or I'll just put it in blue. Or no, I'll use green. We're going to factor this. Remember, completing the square helps you create a perfect square. What does all this green stuff factor into? X squared plus 4x plus 4. Remember, that becomes, well, we still have the 3. That becomes x plus 2 times x plus 2, right? Because 2 times 2 is 4. 2 plus 2 is 4. Completing the square should always give you that, right? Where you get the same terms right there. And I still have this minus 4 on the outside of this. You need to continue with that, okay? And we still have the plus 5 on the outside. Now, since we have two of the same terms being multiplied together, what can we do? Condense them, right? That becomes x plus 2 squared. We still have this 3. I still have this minus 4. And I still have this plus 5. So we're almost there, right? Because remember, we were looking for a times x plus h squared plus k, right? We were looking for this right here. A times x minus h squared plus k. We're almost there, right? Because we have this squared thing, but I have this extra thing right here. So what are we going to do? We are going to distribute this 3 in. This. So I'm going to take the 3 and multiply into this term. So we're going to have 3, 3, and then x plus 2 squared. And then we're going to have minus 4 times this 3 as well. So again, where did this 3 come from? Because I'm multiplying this 3 into the green and this 3 into the 4 right here. That's where I'm getting 4 times 3 from. And we're also still going to have the plus 5, okay? So if you need to pause this, rewind it, go back and look at these steps again. So where do we go from here? Well, let's multiply a couple things out. This negative 3 times x plus 2 squared, we're just going to leave it as that. Minus 4 times 3 is negative 12 plus 5. What can we do from here? This is negative 3 x plus 2 squared. What's negative 12 plus 5? Negative 7. Now it's in the form a times x minus h squared plus k, right? You see that? Oh, now we can tell whether it opens up or down. We can tell what the vertex is. We can find the x-intercepts, the y-intercepts, the axis of symmetry, all that good stuff, right? So right here, let's just describe the vertex. So the vertex in this instance, or first of all, we're going to say it opens down, right? Why does it open down? Because what is A right here? A was negative, right? A is less than 0. Remember, A was negative 3, right? This is A times x minus h squared plus k. Since A was equal to negative 3, we know our curve is going to be doing this, right? It's got to be a U that opens down. And then the vertex is, well, we can tell by examining it, right? Remember, you flip the signs of the x component. It's negative 2 comma negative 7. From there, we could even say, oh, what's the axis of symmetry? We don't need to graph it, right? Remember, axis of symmetry was always x equals the x part of the vertex, which is negative 2. So that was your answer right there. Don't forget, x equals for the axis of symmetry. And then for the x-intercept and y-intercept, I'll let you guys do that on your own. Remember, it's done the same way that we did the last two problems. Remember, for the x-intercept, What are you going to do? You're going to set this to 0 and solve for x. For the y-intercept, what are you going to do? You're going to make x 0 and then work it out and get a number, right? And then you have your points, and then you can graph it, all right? So now let's say if they don't want us to convert it into this crazy form, and they leave it in the previous form that we just had. And again, remember, pause this if you need to, right? And go back and rewatch it. Let's say we had f of x equals x squared plus 4x plus 3. So when I could convert it to that first form, the a times x minus a squared, we're just immediately going to ask, whether it opens up or down, what the vertex is, and stuff like that. So for this, remember, it's in that form ax squared, ax squared plus bx plus c. And remember, if a was positive, it opened up, right? So we already know that. Opens up since a is greater than 0. So we know it's going to be doing something like this, right? So that means your vertex would automatically be a min, right? We already know that right there without even doing anything to the problem. Vertex is a min, or is the minimum point. Now, the second question is, well, what's the vertex? Well, unfortunately, in this form here, we can't tell just by looking at it. That's what was nice about the first form. Remember, it was h comma k. We don't have it in that form right here. We're not going to convert it to that form at all. We're going to use a formula over here. So the formula for this is negative b over 2a, comma, f of negative b over 2a. So remember, this is x, comma, y. This negative b over 2a, remember, those are just coefficients of your equation. So we have x equals negative b over 2a. Well, what is b in this case? It's positive 4. So we have this over 2a, or 2 times, what's a in this case? It is 1. So watch the signs. If this was minus 7x, you would have a negative 7 inside right here, and you still have the negative on the outside. So watch the signs. Remember, this is just giving us the x component of the vertex. This is negative 4 over 2, which is negative 2. Again, that's what's equal to x. We need a y value. Well, according to this vertex formula, it says x is negative b over 2a. Y is f of negative b over 2a. So guess what? Y is equal to f of negative 2. Where am I getting this negative 2 from? It's because that's what this number was, right? Where do we get this number from? The negative b over 2a. You're always going to do that, okay? Whatever number you get from negative b over 2a, you're going to take f of that. What does f of a number mean? You just plug that number back into the original equation, right? And out is going to pop out our respective y value. So negative 2 squared, right? Negative 2 squared plus 4 times negative 2 plus 3. Again, I'm plugging this number back into the original equation for x to get out the respective y value. You're always going to do that. So now you have positive 4 minus 8 plus 3, right? And that gives you a negative 1. So our vertex is, what is it? Negative 2, comma, negative 1. That's the vertex right there. Now let's find the x-intercepts. That's like the third step. And again, how do you find the x-intercepts? You let y equal 0, right? Never changes. So you have x squared plus 4x plus 3 equals 0. Now you can factor it, or we could factor it if possible. Right? Or the second one is use the quadratic formula. You can factor this, but I'm gonna use the quadratic formula really quick just for practice, because remember, sometimes you can't factor everything. So we're gonna have to use this right here. So that's the quadratic formula, right? You don't have to memorize it. I'll write it on the board for you guys. So let's practice with that. So if we do that, x equals negative b. B was 4, so that's minus 4 plus or minus the square root of b squared. That's 4 squared minus 4 times a, which is 1, times c, which is 3, all divided by 2a, or 2 times 1. Again, watch the signs, right? If c was negative 3, wherever you have a c, you would be putting in negative 3 instead. Watch out with the b's, especially if b was minus 4x, or if it was minus 4x, you have minus a negative 4, which would become a positive 4, right? So watch the signs right there. And then we keep simplifying this radical, right? You keep going, keep simplifying as much as possible. So this is negative 4 plus or minus the square root of 16 minus 12, all divided by 2. No, you cannot cancel this 2 out with this negative 4. Remember, the bottom has to go into everything up top. It does not go into everything up top at this point, right? It doesn't go into this root thing. Maybe it will, maybe it won't, but let's find out. So 16 minus 12 is 4. It's still under the root. We still can't cancel this out because of this root right here. But we can say, oh, the square root of 4 is 2, correct? Now we can reduce this fraction. Why? Because the 2 goes into everything up top, right? So this becomes negative 2 plus or minus 1 over 1. Because again, I'm dividing everything here by 2. Can we take this further? Yes, we can, right? Because these are all integers. Those are positive or negative whole numbers. So we can say, oh, this is negative 2 plus 1 and negative 2 minus 1. I'm not putting it divided by 1. I'm not doing this. Why? Because anything divided by 1 is the same thing, right? It's not going to make it any smaller or bigger or change it. But if it was divided by something else besides 1, yes, I'd have to keep it. So we get negative 2 plus 1 equals negative 1. Negative 2 minus 1 equals negative 3. So what does this mean as an answer, right? As an x-intercept? So our x-intercepts are negative 1, 0 and negative 3, 0, right? Because again, all x-intercepts have a y value of 0. So you could have factored this as well, right? And said, oh, it's x plus 3 times x plus 1 and gotten these two results. But you won't be able to factor everything all the time. So you should know how to use that quadratic equation comfortably. And then what was the vertex again? Vertex was negative 2, negative 1, I think, right? Or negative 2, 1. Is that it? No, it's -2, -1. That was it. Yeah. Now the next step is to find the y-intercept, right? So remember, for the y-intercept, what do we do algebraically? We let x equals 0. So if we plug 0 in for x, this is super easy because it's 0 squared plus 4 times 0 plus 3. Okay. So now we get y equals 3. What is that as a point? That is 0, comma 3. Just like that. I'll make a little note. And now let's graph this. So vertex was -2, -1. And we said it was going to open upright because A was positive in this case, which goes 1. The vertex is -1, 0, and -3, 0. And the y-intercept was 0, 3. If we check out our line, or not a line, our parabola, it's a nice U shape again, so we know we're on the right track. We need the axis of symmetry, right? This. Remember, what is the axis of symmetry? It's a line or a mirror that you have to slap on the curve that will make it symmetric about that line. And for parabolas, it's always x equals the x part of the vertex. Axis of symmetry. X, don't forget x equals, and what was the x component of our vertex? -2. There's that answer. Then we need to describe the max or min, right? Well, we know that this is a min point at, and again, it's the vertex. What was the vertex right here? -2, -1. That's it. Now for the domain and range. Well, domain is all the x values that our line exists at. Well, you have two arrowheads pointing to the left and to the right. So if we go to the left forever, that's beginning at -infinity. Of course, the parenthesis, this is also going to the right forever, towards positive infinity. And that gets parentheses as well. Now for the range, notice the smallest y value. Well, it's not going to -infinity because it's not opening down. There's no arrowheads pointing down. So what's that? The smallest y value? -1. Did I have to guess that? No, that actually comes from, you can see it from the vertex, right? So -1, and it is running through that point, so we're going to have a bracket around it. What's the largest y value that the line goes to? Well, it's rising forever, right? Because we have one arrowhead going up. Again, you don't need all arrowheads pointing up, as long as one of them is going up, right? Like if I just had this, that's good enough to tell me, oh yeah, it's going towards positive infinity. Or if I had just this one, again, it's telling me that's good enough that it's going towards positive infinity right there. So those are all your answers. Again, when you're finding the x-intercepts, if you can factor it, sure, go ahead and do it. It'll save you some time. But if you're not good at factoring, or in a lot of instances where you can't factor it, you're going to have to use the quadratic equation, which was this, right? You don't have to remember the formula, but you just have to remember how to use it. And notice that you will have to continue to simplify, right? And sometimes you won't get nice answers like this right here, right? Like remember, if you have the square root of a negative number, you would have I left over, and those would be your intercepts. Or maybe you'll have roots that have decimals, and that's completely possible, okay? But this concludes this lecture right here. Again, there's also the lecture on Alex as well, right? That came with the course that you can always watch. So you can always watch more videos with that. You can also go on YouTube and type in how to graph quadratic equations, all sorts of stuff. Or feel free to email me. And if you want, we can do Zoom sessions over the weekend. You just let me know a time and everything, and I'll be happy to hop on with you, and I can work stuff out on this whiteboard that I have.